how to find the distance from a point to a plane. Sometimes the distance is as the perpendicular distance. Sometimes the distance is something else, maybe measured parallel to some other line. Suppose we have the point x1, y1 and z1, and here is your plane. As you know that equation of the plane is always a first degree in x, y, z. So I'm taking the equation of the plane as ax plus by plus cz plus d equal to 0. Now if you draw a perpendicular to this plane, how the perpendicular will come? I'm just drawing the perpendicular from this point P to this plane. Okay, this is a perpendicular which I have drawn. So making it big. It's a perpendicular which I have drawn. And how to find the perpendicular distance? Perpendicular means you know that this angle will be always 90 degree. So iska direct formula I'm just giving you. So the perpendicular distance, suppose this is Q. We know that PQ is making an angle 90 degree with the plane. So the distance PQ equal to, please write children, write the heading, perpendicular distance from P, x1, y1, z1 to the plane x plus by plus z plus d equal to 0 is given by PQ equal to, what we'll do here is this you replace x, y and z with the given point, that is ax1 plus by1 plus cz1 plus d divided by root of a square plus b square plus c square. Sometimes it is asked in 1 mark also. So this direct formula is it. So now we will do one problem. Okay, to find the distance of a point from a plane, perpendicular distance I taught you now. There can be questions where the distance is not always perpendicular distance. So I'm just giving you one question and then I can explain it. Please write the question. Find the distance of the point 1, minus 2, 3 from the plane. I'm not writing the word plane, but you should understand this. This x minus y plus z equal to 5 measured parallel to the line x by 2 equal to y by 3 equal to z by minus x. Whenever you get a question, you have to first analyze the question, what you have to find out, and what are the given thing in the question. Given means it's a condition given in the question. These two things you have to discriminate. The first part is you have to find the distance of a point from a plane. That's the first part. Then the second part is there is a condition how you have to measure it. That condition is given that measured parallel to this line. So these two things you have to consider, and it is not the perpendicular distance from the point to the plane, but it is a distance. And what type of distance is explained here? It is measured parallel to the line. Let us see one GeoGebra graph. I've just made a graph. Okay. I hope you can see this. The plane I have drawn with the red color plane is there. And you can just see that the equation of the plane, it is x minus y plus equal to 5. And find the distance of the point A, 1, 2, 3. That black color point is our point which is given as per the question, that is A1 minus 2, 3. And the distance of the point from the plane measured parallel to the line. As you know that equation of line is, it is a ratio. So x by 2 equal to y by 3 is equal to z by minus x, that is a line. That line I have shown here with the green color line. Green color is our line which is given as per the question, and the point is marked with black color. You can visualize it. Now I have drawn one perpendicular distance also from A to the plane, which is shown with blue color line segment. You can see that, you can visualize it, children, that blue color line segment, it is a perpendicular distance from point to the plane. So what I just explained in the previous one is how to find the perpendicular distance. We have the direct formula if the plane's equation is given. But this question is not regarding that. This question says find the distance of the point from the plane measured parallel to the line. So obviously you have to just forget about the first concept of perpendicular distance, but the distance to be measured parallel to the line. You can visualize that I have drawn another parallel line which is marked with the dotted lines. Okay, dotted line you can visualize. That line is also green color, dotted line or dash line. That is actually parallel to the given line. And you see this dotted line, it is intersecting the plane at an yellow color point. I am just calling that point as P, okay? This point P. So we can say that AP is parallel to the given line, that is green line. So what actually we have to find is the length of line segment A to this P. Okay. The distance between A and P only you have to find out. Now, how to find it out is, as I have told you in the earlier class, whenever you draw or visualize this 3D geometry distance, if you see a line, you always have to start with a line. And how to start with a line is, I have told you that starting with a line means it is always taking a variable point on the line. Now the confusion comes. There are two lines which we are visualizing here. Which line you have to take first to start the problem? Is it the green line or the dotted green line? We have to take the dotted green line because we have to find the distance between A and P. The distance between A and P. So what's the procedure is, first of all, you should know the equation of the dotted line because we are going to start with that line. To start with that dotted line, we should have the equation of that line. But we have the equation of another line which is parallel to this. So this parallelism you can take to find the equation of the dotted line. Now, how to find the equation of the dotted line? You have to now go to the formula for equation of line passing through a point. So I'm just again going back to the previous this. So we have this red color plane, and here you have this point, your point A, and you have a line which was given with the green color which I have mentioned. This was the equation of the line, but we have to find out the line which is measured, distance which is measured parallel to this line. Okay, so I'm just using another color for that. See, I'm just using this. This is the one line which is parallel to this, and this point is P, and we have to find out this AP. So we have to start with the line which is passing through A and P. For starting with the line means, I'm just calling this as line L. Okay, so first of all, you have to find out equation of L, or you can write equation of line AP. That also we can say. Now, how to find the equation of AP? For that, you have to just recollect the equation of a line passing through a point. You have studied that equation of a line passing through x1, y1, z1 and having direction ratio ABC is, it is a ratio x minus x1 by a equal to y minus y1 by b equal to z minus z1 by c. What is this x1, y1, z1 is your given points. And what is this ABC, which is coming in the denominator, is a direction, a ratio of the line. Okay, so given point and the direction ratio of the line, you can easily write the equation of the line. So now we need to write the equation of this line or the line L. So for that we need two things. Which are the two things we needed? One is the given point, another is the direction ratio. Now look at this line AP. Do we have these two constraints? That is a given point. So we know that you have to find the equation of, so distance of the point 1 minus 2, 3. So our point A is given. This point is 1 minus 2, 3. And to write the equation of the line, we need the direction ratio. So what is the direction ratio of this line? You will apply, you will use the given condition that it is parallel to this line, measured parallel. We are measuring the distance AP only, and AP is parallel to this green line. And the parallelism, if you use, if two lines are parallel, what about the direction ratio? Their direction ratios are proportional. So what is the direction ratio of the given line or green line? It is 2, 3 minus 6. So naturally, the direction ratio of any parallel line also can be taken as 2, 3 minus 6. So we have now the point A and the direction ratio. Then you can write the equation of the line AP. Okay. So equation of line AP you have to write. So equation of AP is your formula x minus, I am not writing what is here, and here also something will come, is equal to y minus this, here nature direction ratio, z minus this by nature direction ratio. So it is passing through 1 minus 2, 3. So you will be filling up the given point here as 1 minus 2 and 3, and नीचे लिखेगा your direction ratio, that also we got, it is 2 3 minus 2 3 minus 6. So here will come 2 3 minus 6. So we have got the equation of the line. Now when you get the equation of the line, how you start with any point on the line L. This line L we will consider it as the point P. So any point on the line B, that is the way you have to start with the start with the plane. Okay. So the next is, please write any point on LB. You know that this we have done in the line. Let this ratio be is equal to lambda. Then any point, how do we find out in the working column? I am showing you this. X minus 1 by 2 is equal to lambda. That means x equal to, you are cross multiplying, you will get 2 lambda plus 1. Similarly, you can have, what is the next? You can have y minus 2. That is y plus 2 by 3 equal to lambda. From there you will get what is y value. Y value is on cross multiplication and transferring the terms, you will get y equal to 3 lambda minus 2. Similarly z also you get. So any point on the line LB, you can take it as the coordinates of P. Okay, it is x का जगह पर हमको लिखना है. Any point means it is a variable point. Okay, so variable point is usually denoted by xyz. So that is why we found this x and y and z. So x is 2, x equal to 2 lambda plus 1, and y is 3 lambda minus 2, and z is, you can mentally also do here. So it is minus 6 lambda plus 3. Minus 6 lambda plus 3. Now any point on the line you have considered. Now to get the value of lambda, what condition you will apply? Any point on the line you have taken as P, and P is the only point which has got a special condition on that. Any point on line, it can be anywhere, but P is the only point which lies on the plane. Okay, so you can again see this GeoGebra graph. That is 2 lambda plus 1 and to get the value of lambda, you apply the condition that P lie on the plane. P lie on the plane. What is the equation of the plane? We have the equation of the plane as x minus y plus z equal to x minus y plus z equal to 5. So if P is a point on the plane, means the coordinates of P is the solution of the equation of the plane. Any point on the curve is the solution to the equation of the curve. Okay, so if this P satisfy the equation of the plane, means the x, y and z can be replaced with the x coordinate, y coordinate and z coordinate of P. So what we get? What we get is, in place of x, you will be writing 2 lambda plus 1, 2 lambda plus 1, then minus, in place of y, you will consider the y coordinate. That is 3 lambda minus 2. And in place of z, you consider minus 6. Minus 6 lambda plus 3 is z coordinate of p, that is equal to 5. And now you can simplify this, children. What you get is 2 lambda plus 1 minus 3 lambda plus 2, opening the bracket, minus 6 lambda plus 3 equal to 5. And what is the value of lambda? Minus 7 lambda is equal to, what is that? 3 plus 2, 5, 6. Here you will get 5 minus 1, and lambda value you will get it as lambda is equal to 1 by 7. Okay, so what value we got for lambda? We got the value as 1 by 7. And now what is that? Coordinates of P we will get, right? The coordinates of P will be what? Then P is, your P ka coordinates hai 2 lambda plus this one is a coordinate. Putting the value there, you will get 2 by 7 plus 1 and 3 by 7 minus 2 and minus 6 by 7 plus 3. So you are getting the point P as coordinates of P as 9 by 7 minus 11 by 7 and 15 by 7. I hope you understood. This is answer. Very, very important question. In the previous years, they have asked this. So while you are writing the answers, this will be the picture you will be creating. Even though I have made something for visual. This point P only we found out now. So again, I am just making you to revise. Equation of plane is given. This point A is given. Okay, and equation of line is given. The question is, find the distance of A from the plane, red color plane, measured parallel to the green line. So what we do is, we are starting with this dotted line, which is the line passing through A and parallel to the given line, because we have to create a line like that, because we have to find the distance measured parallel to the green line. इसलिए हम एक line through A parallel to the green line we find, and find the equation of this line AP. Equation of AP you need to find, because without the line you cannot get any point on the line. So equation of AP you find out, and starting with that line means it is always by taking any point on the line, any point on the line to be taken in terms of lambda, and that you assume that if that point is the coordinates of P, how to find lambda is P satisfy the equation of the plane, because P is a point on the plane. Okay, this yellow color point on the plane. So P satisfy the equation of the plane, you get the value of lambda, and substituting the value of lambda in the coordinates of P, you will get the point P. But that is not the end of the answer. You have to find the distance between A and P, because your question is to find distance from A to the plane measured parallel. So what is the final answer? Therefore distance equal to the distance between A and P. So you will apply the distance formula. A ka coordinates or P ka coordinates, when you apply the distance formula, you know A is, here you can write what is A is your 1 minus 2 and 3. So distance between these, so it is 9 by 7 minus 1 x1 minus x2 whole square plus minus 11 by 7 minus 2 whole square plus 15 by 7 minus 3 whole square. And you will get this as root of 4 by 49 plus 9 by 49 plus 36 by 49, and you are getting 49 by 49, and it is root 1, that is 1 unit. That is the distance of the point measured parallel to the line. Okay, next question. You can also watch this recorded video. Please write another similar type of questions. Find the distance of minus 2, 3, minus 4 from parallel to the plane. Measured parallel to 4x plus 12y minus 3z plus 1 equal to 0. So this is also measured parallel, but it is the distance of the point from the line. See, I have just shown it, you can just visualize. Okay. Now children, our given point is this point 2, minus 2, 3, 4, which I have marked with the white color. I hope you can see this. I'll change the color to green. Okay, this green color point, given point, minus 2, 3, minus 4, and equation of plane. I have not written the equation of plane, but you can make out that plane, red color plane. And there is a line. The line is our green line. Okay, equation of line I have not written. Now the question is, find the distance of the point A from the line measured parallel to the plane. You can see one black color line. Black color line is a line which is parallel to the plane. You can visualize it. This line, black line is parallel to the plane. And you have to find out the distance from distance of A from the green color line. From the green color line, measured parallel. Measured parallel means this black color line is a parallel line, and if you consider the red color point as P, you can say that AP is parallel to the plane. I repeat, AP is parallel to the plane and P is a point on the given green line. Okay, so the required one is the distance between A and P. Now to get the value of P, what is the technique is? In the question we are given the one line. Which line is that? It is a green color one. So we can consider any point on this green line. Okay, any point on the green line you can find out because we are given the equation of the green line. Any point on the line can be taken in terms of lambda, which I have taught you in the previous question. Now, if this variable point becomes this red color point P, you have to create an extra condition on this P. So how will you apply that this P is the required point? For that, you have to apply the given condition. What is the condition given in the question is AP is parallel to the plane. So whenever you get a question, you bifurcate the question into two parts. First part is what is to be found. Second part is what are the conditions given in the question. The first part, what is to be found is the distance AP, which is parallel to the plane, that you have to find out. Now, what is a given condition? The second part, that is, the condition is that it is AP is parallel to the plane. So, जो भी condition है plane का, as I've told you in the earlier class, a plane means immediately you have to think in terms of its normal. A plane and always to be identified in terms of its normal. So this condition AP parallel to the plane, you think in terms of its normal. You know that this normal, this yellow color line which I have shown is a normal. Okay. So what about this normal yellow color line which is passing through P? You can see that it is perpendicular to AP. So instead of applying the parallelism of AP with the plane, you will be applying the perpendicularity of AP with the normal to the plane. I hope children now you understood. P is not rotating, okay. So your point A is here is your point P, here is your point P. You will be applying the condition AP is perpendicular to the normal. And before that, you will assume the point P. Assuming the P will be by using your green color given line. Okay, children, now I'm going to the board. So you are given the plane whose equation is this, and you are given a point here. That point I have taken as A, whose coordinates are -2, 3, -4, and it is measured parallel to the, it is to be measured parallel. Okay. So here is your given line. Here is your given line. You have to find out the distance measured parallel. So I'm just rubbing off the plane now. The plane is, suppose the plane is like this. Okay, this is your plane. Okay, and the normal to the plane this is the normal to the plane which is perpendicular here. Okay, now you have to find out the point P. For finding out the point P, you have to use the line. The given line, let this be equal to lambda. So any point on the line be the coordinates of P. So we can write any point on the given line be P, the coordinates, you have to assume this. It is, you can say 3 lambda minus 2. It is 3 lambda minus 2 comma. Here it is 4 and this, if you cross multiply, you will get 4 lambda minus 3 by 2. So, four lambda minus 3 by 2, because you are finding out y value. Okay, now the z value is 5 lambda minus 4 by 3. 5 lambda minus 4 by 3. I hope you understood this. Now this point P is the required point, but you have to apply another condition to get the value of lambda. For that you will apply the perpendicularity condition here. To apply the perpendicularity condition, you have already learned that if two lines are perpendicular and the direction ratios are A1, B1, C1 and A2, B2, C2, if the two lines are perpendicular, we know A1, A2 plus B1, B2 plus C1, C2 equal to 0. So this condition if you apply, you have to find out now the direction ratio of the lines. Means you are going to apply the perpendicularity condition on AP and the normal. Okay. So the normal is, I am just calling it with the name N. So this is your N. So we have to first find the direction ratio of AP. Okay. So can write direction ratio of AP. And how to find the direction ratio of AP is, if you know the coordinates here as 3 lambda minus 2 and this one and the point A, the direction ratio is the difference in the coordinate. Means iske saath just to not to make the mistake, what I am doing is I am writing here these coordinates -2, 3 and -4. Okay, so that बार बार इधर उधर देखना नहीं है. So direction ratio of AP will be 3 lambda minus 2 minus minus 2. You have to find the difference between the two. Okay. So you'll get 3 lambda minus 2 minus 2. You'll get only 3 lambda. And next one is, you will get 4 lambda minus 3 by 2 minus 3. So this was small simplification हमको करना है. 4 lambda minus 3 minus 6 by 2. So you'll be getting 4 lambda minus 9 by 2, right? The next is 5 lambda minus 4 by 3 minus 4. So it becomes plus 4. Here simplification करने से 3 is LCM and 5 lambda minus 4 plus 12. So finally what you are getting is 5 lambda plus 8. So this is our assumed, this is our direction ratio. So you should not put the bracket. It's a direction ratio. Now the direction ratio of n also, the normal also you have to write, right? Because you are going to apply the perpendicularity condition between AP and the normal. So direction ratio of normal. So what you can write, direction ratio of the normal is always connected with your equation of the plane. The coefficient of xyz is the direction ratio. That means 4, 12 minus 3. 4, 12 minus 3, and even a proportionate value. Proportionate value means you can divide it by 4. No, you cannot divide. Okay. So this is 4, 12 minus 3, and since AP is perpendicular to normal, what you can say, a1 into a2 plus b1 into b2 plus c1 into c2 is equal to 0. So directly I am multiplying and writing 4 into 3 lambda. 4 into 3 lambda, what you are getting is 12 lambda. Then 4 lambda minus 9 by 2 into 6 into 12. So 2 and 12 cancel. You will get 6 into 4 lambda minus 9 plus minus 3 into 5 lambda. So directly I am writing and multiplying minus 15 lambda minus 24 equal to 0. So on calculation you will get 12 lambda plus 24 lambda minus 15 lambda is equal to all the constants I am taking to the other side 54. Okay. So what you are getting is 12 minus 15 minus 3 plus this, that is 21 lambda is equal to this. So what is the value of lambda? Therefore lambda is equal to 78 by 21. We can cancel it with so after putting the value of lambda you will get the coordinates of P and then you find the distance between A and P. So what are the coordinates of P? It will take some more time. So please children, you find out the value of P and complete this answer, okay? Those who have written this can leave.